In this video, you are going to learn about Hess's law, part 1 of Hess's law. So what is Hess's law? There are two ways to determine the amount of heat involved in a chemical change. The first way is measure it experimentally. The second way is calculate it from other experimental determined enthalpy changes. That means calculate it from other experimental data. So in other words, Hess's law is about the calculation about the amount of heat that involves in a chemical change or chemical reaction. Okay, so there are two parts, as I have mentioned before. The first part is about to play around with an equation and to get the enthalpy of the reaction. Play around with it, that means we can multiply by a constant, we can flip it over, we can add two different equations together, we can do whatever we want. Okay, let's try an example. For example, if I have A plus B, that is going to give me C. Let's say the delta H for this reaction, it is let's say 125 joules. Okay, I can do different things about it. First of all, I can flip it over. That means I can have C to 0, A plus B. So what I just did is I switched the order of the reaction. Now, the product from the first reaction here will become the reactant, and the reactant will become the product. Okay, so in this case, if I flip the equation over, what I need to do is delta H of this reaction, we have to put a negative sign. We have to multiply the delta H by -1. So in this case, delta H will be equal to -125 joule. Okay, we can do that. So this is my equation 2, for example. What happened with this? If I multiply equation number 1 by a constant, let's say by 2, so I have 2A plus 2B, that is going to give me 2C. Okay, so this is my equation 3. What happened with the delta H of this reaction here? Because I multiply its ingredient and product by 2, and therefore the delta H for the new equation, I also need to multiply that by 2. When I multiply that by 2, I get 250 joule. Okay, yes, I'm allowed to do that. Okay, next. Can we combine two equations together? For example, let's say if A plus B is going to yield C, and delta H is equal to 125 joule. Okay, so let's say this is my equation 1. My equation 2 will be C can give me E plus F. Okay, just for example. And delta H, let's say in this case, is equal to 75 joules. Okay, am I allowed to combine these two equations? Yes. So what I can do is I add them up. How do I add them? The reactants from each equation will stay on the left side of the arrow. That means reactants will still be reactants, products will be products. I have A plus B plus C. It's going to yield C plus E plus F. Okay, so what happened is I can cancel out the C, and I will have A plus B is going to give E plus F. Yes, I'm allowed to do that. What happened with the delta H? Because I just add up equation number 1 and equation 2. And therefore, for this new reaction equation, enthalpy delta H of the reaction of the new reaction will be equal to, I have to add them up, that would be 200 joule. Okay, I would like to say it is equal to 125 plus 75 joule. That's how I get 200 joules. Okay, sometimes things can get a little bit complicated. That means you have to switch it at the same time, then you have to add them together. All right, let me give you an example. Let's say A plus B, it can give me C. So delta H is equal to 125 joule. This is my equation number 1. All right, let's put it this way. M plus N can also give me C. Okay, so delta H is equal to, for example, 15 joules. This is my equation 2. Okay, so what happened is I would like to know the enthalpy of this reaction. A plus B is going to get M plus N. How do I get to this part? Well, let's look at it. Where can I see the reactant? Is from equation number 1 over here. I can see the reactant, so I'm going to keep it. Where can I see the product? Well, the product is M and N, but it's the reactant over here. So the first step I can do is, from equation number 2, if I flip it over, I am going to get C is going to give me M plus N. What I just did is flip equation number 2 over. At the same time, the delta H of this new equation will be equal to the opposite of this. The negative of this part, it will be minus 15 joule. Okay, so this is my new equation. So equation 3, what I did was I flipped equation 2 over. So now the product from equation 2 will become the reactant, and the reactant from equation 2 will become the product. Now what I'm going to do is I am going to add up equation 1 and equation 3. So equation 1 plus equation 3, let's see what we get. On the left side, I have A plus B and plus C over here. On the right side, I have C plus M plus N. Since I have C on both sides, I'm going to cancel out the C. So what I get is the final equation that I want. What about the delta H? If 1 plus 3, then you also need to get the delta H from equation 1 and then plus the delta H from equation 3. So delta H for this new equation will be equal to 125 plus negative 15 joule. Okay, so that it is 110 joule. Okay, so some of you may want to see the chemical instead of A, B, C, D. All right, so let's look at an example. All right, so let's look at this one. Okay, so these two equations are given. Equation 1 and equation 2 both are given. All right, so I would like to get the enthalpy of this new equation. Okay, in order to do that, let's see the product. Before anything, can I just add up equation 1 and 2? If I add this up, can I get this one? I don't think so, because the NO, where's the NO? NO is over here. So very likely, we may have to flip equation 2. So let's do that. So let's flip equation 2 and see what we get. When we flip equation 2, on the left side I have 2NO2 gas. On the right side I will have 2NO gas plus oxygen gas. If I just flip it, what should I do with the delta H? Okay, I have to put a negative sign in front of this. So delta H for this reaction will be negative of negative 114.2. That will be positive 114.2. All right, I'm going to call this equation number 3. Now, it seems that over here, it seems that I have the 2NO2. All right, so let's add equation number 1 and 3. Equation number 1 plus equation number 3. Let's see what we get. Over here on the left side, I have N2 gas plus 2 oxygen gas. Also, I have from equation 3, I have 2NO2. So I have 2NO2. Okay, on the right side, what do I have? On the right side, I have two NO2 over here, 2 NO2, and I also have 2 NO plus 2 NO and plus O2. All right, so these 2 NO2 I can cancel out. Okay, here I have 2 oxygen. Here I have 1 oxygen, so I'm going to cancel this oxygen. Let's make it cleaner. So I will have N2 gas plus O2 gas. That is going to give me 2NO gas. Okay, so what happened with the enthalpy, with the heat over here? Because I just add equation number 1 and 3, and therefore delta H will be equal to, from number 1, 66.4 kilojoule. Number 3, that will be equal to 114.2 kilojoule. If I add them together, I will have 180.6 kilojoule. Okay, let's see which one. Oh, this is it. All right.